Hello, everyone, and thank you so much for joining me on the second part of our Data Analyst guided project. And this is in support of my Data Analyst educational track. We're going to be looking at today the Kaggle dataset World Happiness Index. So we'll start off our second part of our workflow, the EDA, the Exploratory Data Analysis. We're going to start off by shortening our column names because they're a little bit long. So let's print out df.columns. And we can see here that explained by repeats many times in the column names, and I think that's kind of unnecessary. We also have lots of white spaces. By itself, it's not so big, but it makes it a little bit harder to work with because if you double click, you can't select the whole column names. You actually have to manually drag across them. And that's fine. There's no problem with that. It's just a little bit time consuming, and I prefer to have a little bit easier to work with column names. So what we'll do is we'll make a list of these column names, and I've shortened it out. I've deleted the explained by part, and I've filled all of the white spaces with an underscore. So the way that we would change the column names, we'll go df.columns equals to features short. And so the list that we just made, we're going to assign that list to the columns argument. So df.columns, or sorry, the attribute of the data frame. And this will essentially change all of our column names. We have to make sure that we're keeping the same position. And because this is going to write over column names, we'll see here when we print out columns, we get a nice clean column name list. And we'll take a copy of this right here, and we'll put this in we'll make a new list of our features. But because we're going to be working with the way that we're going to be working with in our exploratory analysis, we don't have need of the ranking country. So having a list when we're starting off our EDA of the column names is a great way to select in and out different features that we want to explore. We'll start off our exploratory data analysis by looking at the 5-point analysis of every numeric column. So we'll go here and we'll go df. We're putting the list of features inside the square, the first square columns. We'll go to describe and parentheses, and we'll get a 5-point distribution of each one of these columns. So you can see here quite a good variation. And it's really important to note that the scale is quite a bit different. We have life expectancy 0.94, freedom of choice 0.74, whereas the happiness index is on 7.82 is the maximum value. So we can see there's quite a bit of different scale between all of them. It's important to note and be conscious of these as we're working through our workflow. So what we're going to do next is we could look at every individual list by itself, but it's a little bit easier. We're going to use the power of programming and do things a little bit faster. So we're going to use a for loop to print out the distributions of each one of these features in our short frame. So what we'll do is we'll go feature in features. So the short list that we created of the feature, the short name. So we'll go for feature in features, SNS, so seaborn dot displot. We'll assign data equals df and x equals feature. And there we go. And this prints out. It'll take a second to run because we're going to generate a lot of different plots, and we'll print out the distributions of each one. If you're a student that's completed this course, you will have access to this. And I just give a little bit of a write-up on each of the distributions. It's amazing how far you can make it in data science without really understanding what the data represents, without having the domain theory of the subject. But as long as you understand the distribution, you can make it quite far in data science up until a point where you need to really start understanding what the data represents. Okay, so we're going to do this a little bit different. We're going to do univariate analysis of the happiness score. So we're going to do the same thing, but we're going to break it up by happiness score. So we have the happiness score here, and we're going to do the 5-point distribution using dot describe. And you can see here we have min, 25, 50th, 75th, and max. So we're going to cut that and make essentially bins of those features. We'll use pd.cut, and this will help in our analysis. So the first argument here that we want to assign is data frame happiness score. Oops, I should put a capital H, happiness underscore score. So we're going to look at just that one column, and we're going to be making changes to just specifically that one column here. So we got happiness score equal, and the second argument is bin. So if we can imagine that you have one column or one bin, you would need to set a maximum and minimum. So you need 2 limits to set one bin. So for 4 bins, we need 5 limits. So we have 0, 1, 2, 3, 4, 5. limits. And then our labels are group 1, group 2, group 3, group 4. So it's really important to make sure that you have 5 limits to set 4 bins, and then you have the 4 bin titles. It's a common mistake. And we'll run that cell. And we're going to do our for loop again to inspect the distributions of each. But now we're going to have a little bit more detail. We're going to separate them by the bins that we just created. So what we'll do here is we'll go for feature in features. We'll do again our SNS dot dis plot. We're going to set our data argument equal to our data frame. X again is equal to our feature. So the same part here, all the same as before. And then we're going to change it a little bit. We're going to make our Y feature equal to the happiness score bins. And I'm just going to copy and paste that. And we'll see happiness score in bins. And let's run this cell right here. And what we can see is it's going to take a little bit longer to run, but we get a nice set of graphics here. And so we get a nice printout, and we can really get some texture of where that weight of each distribution lies. We could also look at something here. I looked at a disk plot, but we could also look at a box plot. So box plot gives us the same sort of separation, helps us break it up a little bit, and gives us some more. And sorry, I got to make sure that we go S. If we're going to look at anything but a disk plot, we have to make sure that we use the plot.show command so that it prints out essentially each graphic each time. So you can see here we get this is a nice, clear, and easy way to see each distribution here. So the happiness score by happiness score, we see a nice growing amount. And I have, again, if you're a student, you would have access to this list. It's good to review this and make sure you understand the comments that I made and how they relate to each distribution.